Hey, it is me again, and I am going to continue going over test 1a, the sample exam, and we'll go over page 3 and maybe page 4 if we have time in this video. Otherwise, I'll make another video for page 4. So the first problem is the normal distribution problem. Suppose the length of a time a person takes to use an ATM is normally distributed, mean of 88 seconds and standard deviation of 20. The first question, what proportion of ATM users between 80 and take between 80 and 100 seconds? And so this is a problem where we need to calculate two z-scores, one for 80 and one for 100. And if you're not using a calculator, you find the area to the left and you subtract the larger area minus the smaller area. So I went ahead and calculated the z-scores already to save a little time. We have a z-score of negative 0.40 for our x value of 80. I can go to the table and look up negative 0.40. That would be 0.3446. I'll go ahead and write that down. We have 0.3446. And then I need to look up a z-score of 0.60. That would be for the value of 100. So I go to 0.60, so that's going to be 0.7257. So that's my larger z-score. And so I take my larger z-score of 0.7257 and subtract the smaller one, and that gives me the area in between. That gives me 0.3811 for my answer. Jumping down to the calculator, this problem is pretty easy on a calculator. I'm looking for an area or a proportion, so I use normal CDF. I need a lower bound, that's going to be 80. I need an upper bound, that's going to be 100. My mean is 88, and my standard deviation is 20. Okay, now I get the same answer using the calculator. The next problem is one of those different types of problems. If I give you a percentile, that means that I'm giving you the area under the curve. And unless I use a word like top 1 percentile, the percentile means an area to the left. So the 99th percentile means the area to the left is 0.99. So I have an area under the curve or percentile, and I'm looking for x. I'm looking for the ATM use times. And so I want to use my equation x is equal to z times sigma plus mu. That formula will be given. I just need to look up a value for z. Again, this is one of those reverse types of problems, so I start in the middle of the table. I go to 0.99 or whatever is closest. That's as close as I'm going to get, and that z-score then is 0.230123. So 0.233. And so I come up here and I take 0.233 times the standard deviation of 20 plus the mean of 88. And that gives me, what does that give me? 134.6. And you want to be careful with these types of problems that you remember units, because we're finding a value of x. X is usually quantitative, so it has units, in this case, seconds. Okay, so jumping to the calculator, again, this is a reverse type of problem, so I go to inverse norm rather than the normal CDF. That's definitely one thing you have to get straight before the exam, otherwise you're not going to do as well as you should. So the area to the left is 0.99, my mean is 88, and my standard deviation is 20. And I just hit enter. And I get about the same answer. Okay, so that will do it for the normal problems. We're going to come down here and do a problem with this histogram. So I'm given this histogram, skewed right, and we have outliers. And the first question is, I want to find where the median will fall, in what interval. I'm not asking for the exact value, but you can pick out where the median is. And so I know there's 40 students. And so if I had them in order of number of pairs of shoes, the median would lie between the 20th and the 21st observation, right? Because I want to split the median up to equal halves. That would be 20 on one side, 20 on the other. So we would want to take the average of the 20th and 21st observation. Now I don't have the data in front of me, but I have this histogram. Whenever you have either a histogram or a frequency table, you have to take into consideration the frequency. So I have 18 people that had between 0 and 10 shoes, 0 and 10, and the next 10 students had between 10 and 20. So I want to find that 20th observation and that 21st. Well, the first 18 observations are somewhere between 0 and 10. So I haven't reached that 20th observation. But the next 10 observations, so those would be observations 19 through 28, right? Because this goes up to 18 and then I have an additional 10. And so there would be observations number 19 up through 28. And so these observations are going to be in there somewhere. And so this would be my median right here. And so that'd be 10 and 20. Okay, so a problem like this, you have to take into consideration the heights of the bars. All right, true or false for the above data is more appropriate to report the mean and standard deviation because they are resistant. Earlier in a problem, we said that they were sensitive, not resistant, so that would be false. The median and the IQR would be more appropriate. So the median, oops, it's not looking too good, slash the IQR would be what you would want to report there. If it said median and IQR, then that statement would be true. All right, the next one is fairly simple. What percent of the class owns more than 40 pairs of shoes? So getting back up to my histogram, here's 40 right here. So more than 40 is this way. And so I count the heights of the bar. I have one observation here, one there. So I have 3 observations out of a total of 40 students. And so that's going to be 7.5%. Okay, great. And we have time to go over the last page on this video. This is what we call two-way table. We have 2 categorical variables. We have the political affiliation, liberal, moderate, or conservative, and we also have gender. Okay, and here the totals are given to us, so that's really nice. If the totals aren't given, then your first step is to get the row totals. So create a column total, so create a row for the column totals, and then the row totals here, so 35 plus 50. And that's going to help us do all these calculations. Okay, what percent of the class is male? Okay, so here I'm just dealing with the gender variable. Nowhere in the question does it say anything about the political party. And so when you're just dealing with one variable, you're either going to be down here for gender or over here. So you're going to be in the margins if you're just dealing with one variable at a time. In this case, it's gender. There were 115 males out of a total of 192. And so I'm going to just take 115 and divide by 192. And so that's equal to 59.9%. You can leave as proportion or percent. It doesn't really matter. All right, next question. What percent of the class considers themselves conservative? Again, only one variable. Now on this one, I don't have anything about gender, so I'm going to be over here. I'm going to be in this column over here because this breaks down the political party. And so 27 out of 192. And so that is equal to 14.1%. Okay, the next question, calculate the marginal distribution for the politics variable. So marginal just means one variable. Nowhere in here do I break it down by gender. And so when you're dealing with the marginal distribution, you're in either the row or the last column, last row or last column. Because it's the politics variable, it's going to be the last column. Okay, and for something like this, I want a label. So I want a liberal. Ooh, that didn't work out. I don't know what happened there. Sorry. I need to get rid of that. Okay, so let's start over. I want a liberal, moderate, and conservative. And then I want to calculate the breakdown of each. So how many or what percent fall in each category. So I'm always dividing by 192. So this is 0.443. The moderates, there were 80 divided by 192. So my labels don't really match up, but you get the idea. And then for my conservatives, there, well, we already did that. It's above. It's a 0.141. And like I said, you can leave it as proportion or percent. It doesn't matter. Okay, so that's, when I say distribution, that means the breakdown or the percent that fall into each category. So the distribution of politics would be the percent that fall in each category of politics. All right, last two questions. What percent of males in the class consider themselves to be conservatives? All right, so this question is a little bit trickier because it takes into consideration both variables at the same time. So we want to know the percent of males that are conservative. So we go back up to our table. Now we're only going to be dealing with this row, this column right here. We want to know what percent of males. So we have a total of 115 males, and let's see, conservative, how many were conservative? So 21 out of the 115 were conservative. And that's equal to 18.3%. Okay, and so those are a little tricky. It's important to get the denominator right. Percent of males, that means I only want to deal with that column. All right, and now the conditional distribution of politics for males. Again, I want to make sure I understand what a distribution is. Distribution of politics means that I want the distribution or the breakdown of the political party, and I'm conditioning it on being male. So I'm only interested in for the male participants in the survey. So I'm always going to be dividing by 115. So again, I can label everything. This is for the males. We'll label it liberal, moderate, conservative. And then the percent, I'm always dividing by the same number. So I have 50 divided by 115. That's equal to 0.435. And then 44 divided by 115. That's equal to 0.383. And we did the last one above, so 0.183 for the conservatives. Okay, so again, always dividing by the same number. And then we also want to do the same thing for the females. By the way, here's the formula sheet. It's going to be very similar on the exam. So above here, now I only want the breakdown for females. So I do this column, taking 35 divided by 77. 36 divided by 77, and so forth. So I'm just going to do this fairly quickly because I think you get the idea. The first one is 35 divided by 77, so 0.455. And then we have 36 divided by the same number, 0.468. Oops. And then the last one is 6. So that's going to be 0.078. And so what would be interesting maybe is to compare the two. It looks like females are more likely to be liberals than males and less likely to be conservatives. Females are also more likely to be moderate than males, 0.383 compared to 0.468. Okay, well, good luck on your exam. I hope you guys do well. There is no video for the other sample test, but there are solutions available.